Good afternoon once more. I'm Mr. Obare Gepffrey from Mathematics Department, Agorosare High School. I want to take you through the topic rotation, and we are just going to give a brief overview of the topic. Because just as rotation is a transformation, our basic prerequisite of this is to look at transformation. And when we'll be looking at transformations, matrix transformation, we'll be looking at rotations, we'll be looking at reflections, and we'll be looking at enlargement. And therefore, it is very necessary for us to look at this topic, rotation. Rotation is a transformation that only changes the position of an object. So rotation will only change the position of an object. The size will remain the same, the shape will remain the same, but the position will remain changed, or the position will be changed. Consider a triangle ABC with vertices A as 2, 4, B as 2, 2, and C as 4, 2. Now, to obtain A prime, which is the image of A, then the image of A we rotate OA about O through the angle of 90 degrees. And we can look at that in our graph. When we look at our graph, we'll see that point this O is the center of rotation. A, B, C is the object. I've given it T as the object. T1 is the image of T after rotation of 90 degrees. And in this case, for this case, it is positive 90 degrees. So, for us to locate the image of A prime, which is here, the first step is to join O to A, where O is the center of rotation. So, in this case, we have used the origin as the center of rotation. The center of rotation can be any other point, not necessarily the center or the origin as the center of rotation. We can pick it as even from 1, 1 or from any other center that can be located in the Cartesian plane. So the first step is to join that we have said. Then measure using a protractor an angle of 90 degrees towards this other side. When we measure 90 degrees from A, then it will move up to this other end. Then the angle in between A and the angle between A and A prime is 90 degrees. Then the same distance from O to A must be the same distance from O to A prime. Therefore, we mark it. So our coordinate of A was 2, 4. Then we look at, when you mark it accurately, you will get that you are landing at -4, 2 as the image of that. Then once you have done that, we do it to B also. We do it to B. For B, we will have the same join B to O, which is the center. Then measure 90 degrees. When you measure 90 degrees from B to B prime, you will find that you are landing B prime at -2, 2, which is the image of B after rotation through positive 90 degrees and mark it. Then similarly we do it to C. OC is the line. OC, I've said, is the line that is joining from point C to the center of the vertices of the triangle. Then you rotate that point C, you measure using a protractor, 90 degrees. Then you'll find that C prime is at point -2, 4, -2, 4, which is the coordinate of the coordinate C prime. That is the image of C. That is the image of C. So that is how, then once you have located the points A prime, B prime, and C prime, then we join the 3 points. Once you have joined the 3 points, then you will have your triangle T1, which is the image of T after rotation of positive 90 degrees. Similarly, we can also do a rotation of negative degrees. A rotation of negative degrees can also be done. A rotation of negative degrees can also be done. When we are doing a rotation of negative degrees, then we note that a rotation in a clockwise direction is taken to be positive, while a rotation in anti-clockwise direction is taken to be negative. Is to be taken in anti-clockwise. I've said that a rotation in clockwise direction is taken to be positive, while a rotation in a clockwise direction is taken to be negative. I.e., anti-clockwise it is positive, in that case positive 90, while clockwise direction it will be 90 degrees. When we rotate the same figure in about 90 degrees, then we'll have the same procedure we used. First, let us join point A to the center of rotation, and I've said our center of rotation is the origin. The origin is 0, 0, then you enclose it in bracket. Then you will also mark that line, use the dotted line the way we have done it here. Then measure 90 degrees in clockwise direction. Then you will end up reaching at 4, -1, as at 4 should be 4, -2, 4, -2 as that image should be 4, -2 at that image. Then we look at point B. You will end up moving at 2, -2. Then we rotate point C. You realize that it is going to be at 2, -4. So when you join those points, it is going to give us the image of that triangle. So we have the image A prime as 4, -2, B prime as 2, -2, and C prime as 2, -4, which is the image T2 under rotation of -90 degrees. So in general, that is rotation. And rotation is also a type of transformation that we have learned that rotation does not change the shape of an object. Neither does it change the size of an object. Therefore, rotation is what we call direct congruence. It's direct congruency. Like when we are looking at two types of congruency, we did say that we have direct and indirect what? Congruency. And in the rotation is one of the direct congruency that we have. Because when you rotate back the object into the, when you rotate back the image into the object, then it will fall on that. So therefore, rotation is, I'm repeating, rotation is a direct congruency type that we have. So maybe when you meet a rotation and you ask which type of congruency it is, please state that rotation is a direct congruency. Now, I want us now to look at rotation through 180 degrees. And there is one unique character with a rotation of 180 degrees. In a rotation of 180 degrees, we find that when you rotate an object in 180 degrees, either clockwise or anti-clockwise, then the image will land in the same position. So, therefore, we can say that a rotation of positive 180 degrees or negative 180 degrees is equals. It will take the object to the same position. The same to a rotation of 360 degrees. When you rotate an object 360 degrees, you realize that the object will remain in its position, it will not be moved. So therefore, rotation of 180 degrees will move the object, just as the same as both the negative and the positive. Just we can look at the diagram here. When you look at the diagram, we look at the point A is rotated through 180 degrees. It is moved to A prime. When you move anti-clockwise, it will be that way, that is positive rotation. Or when we move in anti-clockwise direction, it will still be at that particular point. Therefore, that's why we are saying a rotation of plus or minus 180 degrees does not take the objects at the same position. Then we look at point B, rotated through 180 degrees, joined to the center. Then the center 180 degrees to that. The same point C, join it to the center, and rotate it. This is 180 degrees. Then you find that C will be at negative 4, 2. So those are the coordinates of T3. T3 is the rotation. T3 is the rotation of 180 degrees. T3 is the rotation of 180 degrees. And this rotation of 180 degrees is a common, it can be said, it's something that we can do without necessarily rotating. That's why we want to give it a general rotation. In general, we can say that a point AB rotated through 180, either plus or minus, about XY is mapped onto the point that is 2x minus A, 2y minus B, where x and y is the center of rotation, A and B is the point to be rotated. Now, let us look at an example. When you take point 3, negative 4, when you look at point 3, negative 4, and rotate it about 2, 1, you can do it graphically. Those who have graphs at home, you can try to do it graphically, but we won't do it mathematically, because graphically we have done it, and we can prove that this formula holds even when you use graph. So our formula is 2x minus a, comma, 2y minus b, and we have said that x and y is the center of rotation. A and b is the coordinate of rotation. Then we substitute x, in this case, is our center of rotation was 2, 1, so x is 2, y is 1. Then AB, B is the center, B is the point to be rotated, AB is the center point to be rotated, so that A is 3, B is negative, B is negative 4. So let us substitute 2 into 2, which is the center of rotation, minus 3, which is also the coordinate of the x coordinate of the point to be rotated, while 2 into y, y is our center of rotation, the y center, the center of rotation, the y coordinate of the center of rotation, while b is the y coordinate of the point to be rotated. When you substitute in that equation, we'll have 2 times 2 is 4, 4 minus 3 is 1. So our x coordinate there is 1. Then we'll have 2 times 1 is 2, minus 4 is giving us positive 4. Therefore, we'll have 2 plus 4, which is 6. Therefore, when we rotate 0.3 negative 4 about 2, 1, then we'll have 1, 6 as the image of that point under rotation of 180. Please let us note that this formula only applies when the object is rotated through 180 degrees. It can either be positive or negative. Now, that is to rotation. Our next subtopic, we want to look at how to find the center and angle of rotation. How to find the center and angle of rotation. Given that the vertices A, B, and C are the vertices of our image, A prime, B prime, and C prime, find the center and angle of rotation. Now, to find the center and angle of rotation, then the first step is to join the segments A to A prime, B to B prime, and C to C prime. That is A to A prime, B to B prime, and C to C prime, as that. Then construct 3 mediators. A prime, mediators means the bisector. When you join C and C prime, A and A prime, and B to B prime, you come up with a line. Then that line, we bisect it using a pair of compass. When you bisect line C and C prime, then bisect A and A prime. That is what I've used in this case. When you bisect, then the bisectors will meet at a point. Now construct the 3 mediators A prime, B prime, and C prime. Mark the point O, the center of rotation, where the bisectors intersect. Now O here is the point where the bisector intersects, and that is the center of rotation. Where the bisector meets is the center of rotation. Now we want to move ahead now to find the angle of rotation. Finding the angle of rotation, you can join first A and A prime. We have A to O, then A to O, then to O prime, A, O to A prime, then B, O, B prime, C, O, C prime. When we join these three for this case, I've used B, O, and O, B prime. Then we measure the angle between the center of the angle between B and B prime through the center of rotation. That angle there will give us the center of or will give us the angle of rotation. That angle is going to give us the angle of rotation. So that is how we are going to find the angle and center of rotation. Remember, in this topic, we have been looking at what is a rotation. We have seen on how we can rotate an object through 180 degrees, through negative 180 or positive 180, through positive 90, through negative 90. And again, we have seen that when you rotate an object through 180 degrees, then we have the general formula 2x minus a, comma 2y minus b as the general formula for locating the position or the image of the object without necessarily drawing that particular object on the graph. With that, we have to thank you for listening to us, and I will have a nice holiday. Thank you.